Hello, everyone. This demo is a collaboration between SKT and AWS on the AI-powered SMO for run workload management. CSPs and ISVs, they start to build their own SMO. And for the SMO they build, one piece is missing is the AI/ML workflow. In this demo, we are trying to build a reference design for the AI/ML workflow for the SMO. And on top of that, this demo will also show AI/ML-based resource allocation and optimization, and also seamless workload management. So let's look at the high-level architecture. So normally for the run network, there are two pieces. One is at the remote side, and another one is at the central side. For the remote side, normally it's a CU and DU. It can be our outpost and outpost rack. And the automation part is here. And once we have the network, right, and then we collect the data, that can be PM data, CM data, FM data, and then we put it in S3 and process it. And once we have the process data, we can build the AI/ML workflow, build the AI/ML model on top of that workflow. And based on the model we build, we can adjust resource allocation and feedback and adjust the resource here at the remote side. So let's look at the blueprint, how it looks like. So this is high-level SMO, how it looks like. What we are building is here, highlighted in orange, which is AI/ML workflow based on the ORAN spec, and it's API-driven. So we use API to access those AI/ML services here. So more detailed diagram is here. So for each use case, it may include multiple RApps. So for RApps, when we have the API call, first it will go through the SME, which will authenticate whether this RApp is allowed to access those services. Once it's allowed, it will pass to the different pipeline. It can pass to the training pipeline, prediction pipeline, the policy pipeline, and resource adjustment pipeline, and also data processing pipeline. So the demo we are doing is the traffic prediction. Based on the traffic prediction output, if the output is high, we will add resource to the remote side. So we use SKT's data here, and we have an API call asking, process the raw data. So here we are going to split the data and then store and generate the scaling factor. And those will be feedback and as a response stored at the S3 place. And then we have another RApp called training. So based on the process data, it will go through here and then go through the training pipeline and save the model in the model registry, and response, the training is done. And then we have prediction, same flow, and it will tell where the prediction is stored. And based on the prediction output, then we will trigger, whether A1 policy will change. If it changes, then it will invoke the O2 resource change. So the demo here, we show 3 API calls. So first API call is a training API call. After we receive the training API call and authenticate it, here is the implementation for the training pipeline. So first we invoke the SageMaker process job and do the training. Once training is done, we will list the model, where the model is, and then we will save the model to the model registry. And then we can have another API call, which is a prediction API call from another RApp. So let's look at the details for the prediction pipeline. So first, similarly, we will invoke the SageMaker endpoint. And after the SageMaker endpoint, we will deploy the model we just trained. And once that model is deployed, we will load the test data and do the prediction. For demo purpose, we will also have a visualization component, which will compare the real data versus predicted output. At the end, we will clean up all the results to save the cost. Let's take a look at the prediction output here. We use LSTM for this prediction. So you will see here is the blue line is real data, orange line is predicted output. And let's see how we adjust the resource. So you will see here, this is right now the pod running on a machine. And you see here, we have an API call. So what it does is, it will compare the prediction output with a predefined threshold. The predefined threshold we set is 0.15. You see here the prediction output is, is higher than 0.15. So that means we need to add a new resource. And then event to trigger is to add resource. So all those will automatically trigger a flow, which will deploy new resource here. So you will see here, a new pod has been deployed because the prediction output is higher than 0.15. So that's all the demo.